imagine you're out and you snap a photo of this, like, strange blistering rash on your arm, right?
Oh, yeah, we've all been there with the WebMD panic.
Exactly, the spiral. But instead of that, you drop this photo into a WhatsApp chat, and instantly you get a diagnostic breakdown. And not just a guess, but a breakdown that has been logically verified by basically a parallel boardroom of 1,000 doctors.
Right in the chat app.
Right next to the group chat where you're, trying to organize brunch with your friends. No waiting rooms, no endless scrolling, just clinical-grade analysis living right there on your phone.
It sounds totally like a science fiction pitch.
It really does. But it is not.
Yeah.
That is the actual reality that Meta just dropped on the industry with this early April 2026 release of Muse Spark.
Yeah, and I mean, the broader context here is really what makes this release so disruptive. Because if you think about it, we've spent the last few years watching these tech giants build what are essentially monolithic God models.
Right, these massive things.
Exactly. We're talking systems with trillions of parameters. And by parameters, I mean like the digital brain cells or variables the model uses to actually make decisions. And they have to be housed in these massive compute clusters.
I mean, literal warehouses full of whirring servers, right?
Yeah.
Drawing the power of a small city.
Yeah, exactly. Which is, completely unsustainable for everyday mobile use.
Which is exactly why the technical briefs we are looking at today for this deep dive are causing such a massive stir. Because Meta Superintelligence Labs has released their first proprietary frontier model, and they purposefully designed to be small.
Yeah, they went the complete opposite direction.
Right. So the stated mission of today's deep dive, for you listening, is to cut through all the marketing hype and really figure out how a model that is designed with this hyper-efficient footprint is suddenly rivaling the heavyweights of the entire industry. We really need to look into the hood.
We do, because the architecture is fascinating.
It is. I mean, it's kind of like everyone else in the AI race has been building these massive gas-guzzling monster trucks, right? And Meta just rolled out a hyper-efficient sports car that somehow packs a whole boardroom of scientists inside the trunk.
That is actually a brilliant analogy.
Thanks. So looking at the architectural white papers, they use 3 specific words over and over to describe Muse Spark: small, fast, and natively multimodal. And that word, natively, seems to be the linchpin of this entire thing.
It is. Natively multimodal is basically the fundamental shift away from how we built AI even 2 years ago.
Okay, break that down for us.
Well, before this, if you wanted a system to understand, say, a photo of a receipt and then tell you the total, you basically had to duct tape different specialized models together.
Duct tape them.
Yeah, I mean, you had a vision model that acted like the eyes, right? It would translate the pixels of the image into a text description, and then it handed that text over to a completely separate language model to actually do the reading and the math.
So it was essentially playing a game of internal telephone.
Precisely. The visual model whispers a description to the text model, and by the time the text model actually processes it, you lose all these little nuances. Latency spikes up, and, the computational energy required to run both of those models at the same time is just massive.
Right. So how does the native approach fix that?
The native approach just eliminates that translation phase entirely. So Muse Spark was trained from day one on text, images, and speech simultaneously. It maps them all into the exact same mathematical space.
Wait, so it's not translating a picture into words first?
Exactly. When it, sees an image or hears spoken audio, it isn't generating a text description in the background. A picture of a dog, the audio of a bark, and letters DOG all trigger the exact same conceptual neighborhood in the model's neural network.
Oh, wow.
Yeah, it's a completely unified form of comprehension.
Okay, so that totally explains the efficiency leap. Because if the model isn't constantly translating data types back and forth, the processing overhead just plummets, which gives us the fast and the small components. But I have to point something out from the release notes, because there's this glaring contradiction.
The output bottleneck.
Yes. The system natively processes images, text, and spoken speech all at once. Yet Meta explicitly notes in the briefs that Muse Spark currently has a text-only output.
Yeah, I know. It feels really restrictive at first glance.
It feels bizarre. I mean, it's like having a genius friend sitting across from you who can simultaneously listen to a complex symphony, watch a foreign film, and read an advanced physics textbook, right?
Right.
All at once.
Yeah.
But then when you ask them for their thoughts on it, they absolutely refuse to speak and will only communicate by, sliding a handwritten note across the table. Why build this incredible native perception if you are going to bottleneck the output like that?
Well, the bottleneck is actually a very deliberate strategic choice by Meta to preserve compute power. You basically have to separate the cost of understanding data from the cost of generating data.
Okay, how so?
So, comprehending an image or an audio file natively is highly efficient in this new architecture. But generating high fidelity, natural sounding audio with zero latency, or like synthesizing a brand new complex image from scratch,
That takes a lot of power.
it is computationally brutal. It eats up massive, massive amounts of memory and processing power.
Ah, okay, so painting a picture just takes a lot more juice than writing a sentence about one.
Fundamentally, yes. By constraining the output to just text for this initial release, Meta frees up a tremendous amount of computational bandwidth. Basically, they are prioritizing the model's reasoning capabilities over its presentation skills.
That makes a lot of sense.
Yeah, when you hand Muse Spark a really complex multimodal task, every ounce of its processing power is dedicated to analyzing that input through what they're calling visual chain of thought reasoning.
Visual chain of thought.
Right, it breaks down the visual components step by step and reasons about how they actually connect. If it were also, trying to reserve memory to synthesize a human voice to reply to you, the depth of that reasoning would suffer immensely. So it's a temporary constraint, but it's the exact mechanism that allows a small model to maintain such high reasoning capabilities.
And the downstream effect of that efficiency is really the most radical part of this entire Muse Spark release. Because the model isn't wasting all these resources trying to be an image generator, and because its native architecture is so lean, it doesn't need to live in a warehouse of servers.
Yep, it lives right in your pocket.
Exactly. Pushing frontier AI out to the edge, meaning onto the local devices themselves, it just changes the entire usage dynamic.
It really does.
The sources outline integration directly into WhatsApp, Instagram, and Meta AI. So the model is conducting complex product comparisons directly through your camera lens, natively inside the apps billions of people already use every single day.
Yeah, that distribution is wild.
But the specific use case that really stands out in the benchmark reports is its specialized foundation for health and nutrition queries. They fed this model training data from over 1,000 physicians.
Yeah, and we really need to define what that physician training actually entails, because it is the difference between simple pattern matching and true clinical logic.
Okay, let's ground this in a real-world scenario for the listener. Say you are at a cafe, you point your phone at your plate, snap a photo in WhatsApp, and ask the Meta AI chat for a breakdown. What is fundamentally happening under the hood that separates Muse Spark from, say, just a generic large language model trying to guess what you're eating?
Well, a generic model basically operates on statistical probability based on billions of random internet images it was trained on.
Right.
So it looks at the pixels, it recognizes the general shape of leafy greens and maybe a piece of protein, and gives you an educated guess. It'll say, that appears to be a chicken salad, roughly 400 calories.
So it's acting like an incredibly well-read search engine.
Exactly. But Muse Spark, on the other hand, utilizes RLHF, which is reinforcement learning from human feedback. And specifically, feedback from those 1,000 physicians and dietitians you mentioned.
Wait, so doctors were actually grading this thing?
Yeah, these experts didn't just tag photos of food, they evaluated and graded the AI's step-by-step reasoning process.
Oh, wow. So they trained it on the how, not just the what.
Precisely the distinction. Because of that medical-grade training pipeline, Muse Spark employs that visual chain of thought analysis. It doesn't just identify salad, it identifies the specific varietal of the greens.
Are you serious?
Yeah. It estimates the sodium content of the dressing based on its visual viscosity and texture in the photo. It cross-references the char marks on the protein against medical-grade nutritional databases to calculate advanced macronutrient breakdowns. And then it can contextualize all of that against something like your personal inflammatory diet protocol.
That is insane. It's applying actual diagnostic rigor to a casual lunch photo.
It is.
But, okay, bringing that level of heavy scientific-grade reasoning into a highly trafficked casual app like Instagram brings up a massive physical limitation. I mean, if I have a model doing clinical logic and visual chain of thought reasoning directly on my smartphone, my battery should be completely dead in 3 minutes.
Oh, absolutely.
The phone should literally be overheating in my hand. So how does the architecture prevent a total meltdown?
So the solution to that hardware limitation is a really cool concept called dynamic compute allocation, which Meta has branded as the 3 gears of cognition.
Right, the 3 gears. The technical briefs outline these as instant thinking and contemplating modes. Let's actually break down the mechanism of how these save battery and processing power.
Sure. So the core philosophy here is that not every question requires the entire brain to wake up.
Makes sense.
When you ask a standard model a question, whether it's, what's the capital of France or solve this quantum physics equation, it often runs the query through its entire massive parameter network no matter what, which is incredibly wasteful.
Right, so it's basically firing up the entire city grid just to turn on a single light bulb.
A perfect analogy, yeah.
Yeah.
Muse Spark completely avoids this by dynamically shifting gears based on the complexity of your prompt. So the instant gear is the default.
Okay, what does instant do?
It uses a very small, highly optimized pathway of the neural network. It's built for low latency, quick conversational responses. So if you just ask for a recipe or the weather, instant mode handles it using minimal battery and minimal compute.
Okay, so then we step up to the thinking gear.
Hmm.
The white papers note that this is a step-by-step chain of thought mode for complex problems, and it actually drives most of the benchmark results.
Right.
To me, this sounds like the equivalent of sitting down at the desk with a pencil to work through a page of algebra,
Yeah.
rather than just shouting out a gut reaction.
Yeah, that's exactly it. The thinking mode selectively activates deeper layers of the network. It actually slows down the output generation to allow the model to verify its own logic sequentially. But the true architectural breakthrough, and the reason this tiny model can rival the industry giants on scientific benchmarks, is that third gear.
The contemplating mode.
Yes.
Now, the briefs reserve this exclusively for highly demanding scientific tasks, and they use a very specific phrase over and over to describe it: multi-agent orchestration. Now, I have to push back here because multi-agent orchestration sounds like a classic Silicon Valley marketing buzzword.
I know it does.
Right. Like, are you telling me there are actually multiple separate AI models running simultaneously inside my phone when this gear kicks in?
I am. It is not a buzzword. It is a literal structural reality of the model. In standard AI architecture, a single neural network processes a prompt linearly and spits out an answer. But in contemplating mode, Muse Spark basically fractures its unified persona.
It fractures.
Yeah, it acts as a manager delegating tasks to specialized subnetworks, or what they call agents.
Okay, walk us through the actual mechanics of a prompt triggering this boardroom of agents.
Okay, imagine you upload a photo of a whiteboard, and it's covered in a really complex multivariable physics calculation, and you ask the model to spot the error.
Okay, pretty heavy task.
Very heavy. So the initial layer of Muse Spark analyzes the request and realizes a linear guess is going to fail. So it shifts into contemplating mode. The manager agent spins up Agent A, and it instructs it purely to break down the visual math into raw text equations.
Just transcription.
Exactly. Then it spins up Agent B, assigning it to verify those formulas against established laws of physics. But crucially, it also spins up Agent C, whose sole directive is to actively challenge and aggressively debate Agent B's assumptions.
Wait, are you serious? They are actively fact-checking each other in the latent space before even showing me the answer.
They are literally penalizing each other's logical errors in real time. These agents work in parallel, passing data back and forth. Agent C might flag a variable translation error made by Agent A, and the manager agent just oversees this internal debate. Only when a mathematical consensus is reached does it synthesize all that work into the final text output you see on your screen.
Wow. That mechanism explains so much. I mean, it's taking longer to reply,
Yeah.
which is why it obviously isn't the default mode for a quick chat, but it allows a fundamentally small model to tackle really high-level science.
Yeah, it is punching exponentially above its weight class because it's essentially crowdsourcing the problem to its own internal experts.
Which naturally leads us to the ultimate question, right? If it has this highly sophisticated internal boardroom, how is it actually scoring on the global stage?
Right, the benchmarks.
The benchmark battle. The reports are fascinating because the story they tell is incredibly mixed. On one hand, the contemplating mode is going toe-to-toe with absolute giants like Gemini DeepThink and GPT-5.4 Pro. It is dominating in health metrics, posting a HealthBench score of 42.8, which is just staggering for a model of this size.
It really is unprecedented.
And it's also crushing multimodal tasks thanks to that native architecture we talked about.
Yeah.
But then you look at the coding and software engineering benchmarks, and Muse Spark falls notably behind Claude and GPT-5.4.
Yeah, the coding deficit has been the primary target for industry analysts over the past week. A lot of critics are pointing to those specific numbers as proof that Muse Spark isn't a true top-tier frontier model.
And I think those critics are completely missing the point.
Oh, really?
Yeah, I mean, they're measuring a specialist with the yardstick of a generalist. The sources explicitly state that Muse Spark is just the starting point of the Muse family, with larger enterprise-scale models currently in development. If the immediate goal is to deploy a fast, highly secure, vision-based health and science assistant directly into the WhatsApp and Instagram interfaces of billions of users, why do I care if my Instagram assistant struggles to write complex Python scripts?
You're totally right. Honestly, the obsession with coding benchmarks is just a hangover from the previous era of AI development.
Right.
For the last 4 years, the ability to write flawless code was the ultimate flex. It was the proxy we used to measure an AI's overall logic and quote-unquote intelligence.
Exactly.
The thought process was, if it couldn't code, the industry assumed it couldn't think.
And it all goes back to that God model pursuit we mentioned earlier.
Yeah.
Everyone wanted to build the one singular oracle that could cure diseases, write poetry, and build software architectures all at the exact same time.
And we are really discovering the physical limits of that approach. Building a monolithic master of all trades is incredibly inefficient. What Meta is proving with Muse Spark is that the era of the God model is giving way to the era of the hyper-specialist.
A total paradigm shift.
Yeah, they made a strategic architectural trade-off. They intentionally accepted lower performance encoding software in order to achieve a highly efficient, small compute footprint that absolutely excels in visual reasoning and health diagnostics. Because those are the domains everyday users actually engage with when they pull out their phones.
It is a profound shift in philosophy.
Yeah.
We don't need one massive brain to do everything. We need highly optimized, specialized brains deployed exactly where we need them. By embedding this native multimodal architecture and these three gears of reasoning into everyday apps, Meta is fundamentally democratizing access to clinical-grade analysis.
They really are. They've established a highly functional baseline here. And from here, they can scale the Muse architecture up for the larger models coming later this year, which will tackle those heavy enterprise encoding tasks. But starting small and specialized was just a brilliant adoption strategy.
It really completely reframes how we think about the tools already sitting on our home screens. I mean, we are transitioning away from AI as a heavy desktop destination that you have to purposely log into.
Right. It's just there now.
It's now an ambient assistant with distinct gears of reasoning, living right next to our most intimate digital conversations, ready to analyze our diet, verify our physics homework, or just casually chat.
It's going to change everything about how we use our phones.
It really is. Now, as we wrap up this deep dive into the technical architecture of Meta's Muse Spark, I want to leave you, the listener, with a final thought to mull over. It's something that wasn't explicitly spelled out in the benchmark reports, but it naturally flows from the reality of this technology living inside our social applications.
Oh, I'm curious.
Well, if the very places we go to connect with our friends and family now possess a contemplating mode. I mean, if you have a literal parallel boardroom of AI agents trained by thousands of physicians and scientists sitting actively in your chat bar, how is that going to shift your relationship with the actual human beings you're messaging?
Wow. Yeah.
The next time you open WhatsApp to send a photo to a friend, asking for their advice on a weird rash, or trying to figure out a complex problem at work, how long is it going to take until you realize you'd rather just consult the hyper-intelligent hive mind sitting right there in the search bar instead? It is a brave and slightly strange new world for human connection.
It definitely makes you think.
It absolutely does. Thank you so much for joining us on this deep dive into Meta's Muse Spark. Keep questioning the tech around you, keep exploring, and stay curious.